Welcome to Unit 3, Lesson 5. In this lesson, we're going to look at how the monopolist finds the profit-maximizing quantity to produce and the price to charge. Remember, now that we're looking at monopoly instead of perfect competition, they have complete market power, which means the ability to set whatever price they want. So they get to choose a price now, in addition to a quantity, and see which combination maximizes their profit. Luckily, there's going to be some concepts we'll carry over from perfect competition, which will, I think, make this pretty easy to pick up. There's some elements of it that are more complicated, but the basic concept that the firm maximizes profit where marginal cost is equal to marginal revenue remains the same, and that's kind of the key to this whole thing, is remembering that rule. Okay, so what we're going to start off with is one of the same slides that we used in the last lesson, where we looked at how this monopolist, this was the De Beers Diamond Monopoly example, finds its marginal revenue as they increase the quantity of output, how that affects the additional revenue that they take in as a result of that. Remember, the marginal revenue is less than the demand. At some point it gets negative. If you graph them together, it looks kind of like this. Remember that these two columns on the left represent the demand curve, and that's kind of the monopoly's what they're given, what their starting point is. They've got to work within the confines of the demand curve. They can pick any level of output. They've got to charge the price that goes with that level of output as given by the demand curve. They can't just say charge $800 and expect to sell 15 units. If they want to sell 15 units, they've got to charge $250. Okay, so if they can choose any level of output along that demand curve, which is the one that they'll choose? We'll go back to our profit maximizing rule, marginal cost equals marginal revenue, or the other way that we thought about that is keep producing as long as marginal revenue is greater than marginal cost. We don't have cost data yet, so we need to add that. We'll say that the marginal cost of producing diamonds is equal to $200 per diamond per unit. And let's also say that that is constant, which is not usually how we see marginal cost. Remember, we usually see marginal cost as upward sloping as a result of diminishing returns. But just for simplicity's sake to start off, let's consider marginal cost as a horizontal line like that, constant at $200. Another way of thinking that is, if we did the marginal cost, no matter how many diamonds we produce, the marginal cost is going to be, of each additional diamond, is $200 to produce an additional diamond. So now going back to our profit maximizing rule, using the table, we should be able to figure out what the profit maximizing level is by comparing the marginal cost and the marginal revenues. As long as the marginal revenue is greater than the marginal cost, we should produce that additional unit of output. So I'm comparing here, going down the row, 550 versus 200, yes, we keep producing. 350 versus 200, 250 versus 200, and then stopping here. We wouldn't produce the 9th diamond because that only brings in $150 in additional marginal revenue, but it costs us $200 to produce that 9th diamond. So we stop here and find our profit maximizing price and quantity is given by the demand curve. So if the marginal cost is $200, and this is our demand curve, then the profit maximizing price is $600, and quantity is 8 units. Then we can go through the same way we did before to find what profit the firm will make by going total revenue minus total cost. Total revenue, we just multiplied price times quantity, so $4,800. Minus the total cost, we said that it cost $200 per diamond to produce. So we multiply 200 by the quantity of 8, 1,600. So we're going to get a profit of $3,200 on these diamonds, or $400 per unit if you were asked for per unit profit. So that's how you find it with a table. Again, it's very similar to what we did with perfect competition, so hopefully you can pick this up rather easily. You just compare the marginal revenue and marginal cost and stop at the last time that the marginal revenue is greater than the marginal cost. Since marginal revenue is going to be falling, as we see from the shape of this, then at some point it's going to cross through this marginal cost, even when marginal cost is constant. And by the way, we can just put these together, and we should see that that intersection of marginal cost and marginal revenue should be our profit maximizing quantity of 8. And then the price of 600, remember this is 200, but the price of 600 we can find by going right here, because that's what's given by the demand curve. Remember, the demand curve comes from these two columns here. So we know that's 600, that's 8, where MC equals MR. So that, in fact, and we're going to shift now to finding this on the graph, that's what's shown on this slide. That exact graph with this data. You've got the demand curve given by the table above, the marginal revenue line, again given by the table above, and then here's our marginal cost of 200 as a horizontal line. The intersection of marginal cost and marginal revenue with the profit maximizing quantity of 8, and the price given by where 8 is on the demand curve at 600. So profit maximizing price of 600 and quantity of 8. Sometimes we'll be doing this without numbers, often really without numbers and just with a graph. And you want to be able to show, here's the profit maximizing price and quantity. So here's the steps by which we'll do this. First, find marginal cost equals marginal revenue point. That's A. Second, that's the quantity. So draw a line down to the quantity. Line down to the quantity 8, QM. Then extend that line up to the demand curve. Extend up to the demand curve up here. That's point B. And then extend that over to the y-axis to get your profit maximizing price. There's our price of 600. Finally, last step here to show your profit. Notice that that is shown here on the graph this way. To get the profit, we're going to drop a line from the demand curve to the average total cost curve. Let me do that in a new color with green. So again, we're starting at B. The average total cost in this example is equal to the marginal cost. We're assuming no fixed cost, and you'll see that in some of the problems that we do. If there's no fixed cost and the marginal cost is constant, the marginal cost is equal to average total cost. We just start with this kind of example because it makes it simpler. So we drop a line down from the demand curve to the average total cost, which is back at A. That's the right-hand side of our profit box. And then we just make the rectangle out of the rest of that. So there's our area of profits. So drop a line down from the demand to the ATC, complete that rectangle for the area of profits. So there's the method of how you do this on a graph. Again, this is a graph with a constant marginal cost, which is not the typical thing that we see. We'll go to the next slide to see the more usual way that you see a monopoly graph. Here's our, again, more typical upward sloping marginal cost curve and U-shaped average total cost curve with the marginal cost cutting through the average total cost at its minimum point. We still have the monopoly standard demand curve and marginal revenue line. This one doesn't cross below the quantity axis, although it would theoretically eventually. We don't need to extend it to show the profit maximizing quantity. Again, so we go through our steps. Find MC equals MR. That's A. Use that to find the profit maximizing quantity. Extend that down to the quantity axis. There's the quantity QM. Now extend that up to the demand curve, point B, and over to find the price, PM. So there's this profit, this monopoly's profit maximizing price and quantity, QM and PM. Then to find the profit, we go back to the demand curve, extend the line down to the average total cost. So all the way down to C here. And then there is the right-hand side of our profit box. complete that rectangle to show the area of profit. Often monopoly graphs are drawn where the ATC is above the MC equals MR point. I'll show you what I mean here. Here's marginal cost. What if the ATC was, say, here? So from this, you should be able to, again, show the monopolist's profit maximizing quantity and price, and show the area of profit. So let's go through our steps. 1, find MC equals MR point, right there. Drop that line down to the profit maximizing quantity on the x-axis. Next, you extend that line up to the demand curve and over to find the profit maximizing price. So there's our price and quantity. And now the area of profits, back to our demand curve, down to ATC, so stop there. Extend that over, there is our area of profits. We can call that the average total cost. That part right there. Okay, so that's the method. We will do a number of problems, examples in class where we use both tables and just sketch out graphs. You need to be able to do it in either or both ways. There's usually an AP free response question that has you deal with the monopoly graph, usually without numbers, although sometimes with. And then there's multiple choice questions where you have to deal with numbers and find the marginal revenue, find the profit maximizing price and quantity, and amount of profits. See you in class.